All right, this is part 2 of lesson 4.7. You can go ahead and do this proof and pause right now and check back for the answers. All right, so we're going to separate overlapping triangles to try and prove. So we are trying to prove ABD is congruent to the two big ones. Now, I think the way we're going to do that is we have this side in common already, AB, and I can use the information to show that these two triangles, the color here, these two triangles are congruent. And then using the corresponding parts of those, I can get those two are congruent. And then the last thing I'm going to do is add these two pieces together from both of them and show that they're equal. And use side, side, side to show the two triangles are congruent. All right, I'm going to start with my givens. And remember, here's what I'm doing first over here. I'm going to show that this triangle is congruent to this triangle. And I'm going to do that by using angle, angle, side. So I have that angle C is congruent to angle D, given. And I have angle BED is congruent to angle ABC. And that's by the vertical angle theorem. And I also have that AE, segment AE is congruent to segment BE. That's given. So put all three of those together and we have angle, angle side, triangle ABC is congruent to triangle BED. Now from that we have EC, segment EC is congruent to segment ED. And that's the corresponding parts of congruent triangles. And from that we also have AE is equal to BE, and EC is equal to ED. That putting those two together, and the reason for both of those is the definition of congruence. And since those two are equal, and with my given, I can say that AE plus ED is equal to BE plus FC, and that's just the addition property of equality. I'm combining those two statements. And from that I get AB is BC. That's just combining these two to make AD and these two to make BC. So that is the segment addition postulate. And so I get, ooh, that's the reason why. All right, so we have AD is equal to BC by segment addition postulate. And from that, we get AD is congruent. Segment AD is congruent to segment BC. And that's just the definition of congruence. And that's one of the three things we need to show that. Remember, in the end, we want triangle ABD is congruent to triangle EAC. And I said I was going to do that using side, side, side. So we have one of the sides here. We need the other to show the other two sides. Over here, I have, since these two triangles are congruent, the corresponding parts, one of which is side AC is congruent to side BD. And the last thing that we need is the side they both have in common is certainly congruent to itself, and that's the reflexive property of congruence. And so we have three sides that are congruent, so we can use side, side, side. All right, we know A is congruent to itself. We also know that AD is congruent to AD, congruent to itself on that one. Again, A is congruent to itself. AD is congruent to AB. We also know that this angle is congruent to this angle, because it's given. In this one, we have A is congruent to itself. AC is congruent to AE. And we have angle C is congruent to angle E, that's good. And then the last one we have D is congruent to D, of course. And that's the vertical angles in there. We have this little side is congruent to this little side, and that's given. Or that's part of the original. And we also have E and C are congruent. So which triangles are congruent by angle, angle, side? We have triangle ABC. It's congruent. Triangle ABE by angle, angle, side. And we get that because CAB is congruent to ABE. Angle ABE, that's given. Angle C is congruent. Angle E is given. And AD is congruent to AB, the reflexive property. Which triangles are congruent by angle, side, angle? Triangle ACF is congruent to ABD. And triangle FDE is congruent to BC by angle side angle. I'm going to pause and write down the reasons. All right, there's the reasons. So how can you prove BD is congruent to FB? Use so to do that, you would show triangle ABC congruent to triangle ABC by angle side, and then you would show triangle FDE congruent to triangle ABC by angle side angle, and then you would use CPCTC to get that BD is congruent to FD. All right, that's a wrap.